5 fused vertebrae. And then basically the rest of everything is going to sit in that sacral canal. And then at the end, you've got your tailbone. The tailbone becomes really popular as the weather turns to like this. And we start seeing sheet ice in parking lots. Because the move is, right? So what happens is, look, there's nothing solid around this. It's just the tissue of your butt. And when you land like that, there's nothing to support it, and it's just kind of protruding out, it snaps. And there's a lot of nerve endings in this area, so all that inflammation and irritation can cause some real pain. And it's so much pain that like they give you a rubberized toilet seat to bring around and sit on for the next couple of weeks. That way you have some chance to heal. True story, the drummer in my old band busted his tailbone like this for the next 3 months. Every gig he had 2 of these so he could keep drumming for it. All right. Now, also with this is the sternum. The sternum is a point of attachment for the muscles on top. Yes, it's protective. Yes, these ribs are protective. But really, the sternum here, this flat bone, is so your pectoralis major muscles can bind and you can get some limb movement on top of the system. We've got the body, which is the main part. We've got the manubrium, which is what your clavicles are going to come in and articulate against. And down here we've got the xiphoid process, a nice, beautifully engineered spear point right next to your heart and lungs, which this becomes a problem, right? Especially for goalies in lacrosse and hockey, and that's one of the reasons why they wear that big thing on their chest, is to avoid that being broken and jamming up into your diaphragm, heart, and lungs. Right? So that xiphoid process is necessary. What it's doing is hooking up your rectus abdominis muscles to your pubis. And so when you're doing a sit-up, what's happening is your xiphoid process is pulling the top half of your body towards your pelvis by way of its connection to the lower inferior part of your ribs and that xiphoid process there. It's also a point of connection for your diaphragm, which you're going to need to breathe. So it's an engineering flaw, but that flaw has its advantages. Yes? Question? Okay. The first 7 ribs are your true ribs. So named because they have an articulation on the spine in the back and their own articulation in front on the sternum. Once you get ribs 8 through 12, those ribs are all connected as a group, or they're not connected at all. So that's why we call these the false ribs. They're just as legitimate acting as ribs as your true ribs. It's just a matter of attachment, right? These last 2 ribs right here, your floating ribs, they're not attached to anything. These are your most commonly broken ribs. For those of you into plastic surgery and the whole Hollywood wasp waist look, these floating ribs are the ones people get removed to give you the extreme hourglass shape, if that's something that you're looking for. I feel like it's kind of ridiculous. However, they are there for a point, right? But some people decide that those need to go, and they get them taken out. So that's the story with the ribs, and that's your axial skeleton. Questions there, guys? All right, so from there, we move into your appendicular skeleton, getting the appendages to move. And so one of the key features of getting your limbs to move is the muscles closest to your torso need to have a whole lot of size. That way you get the power. But if we don't have a whole lot of surface area on the bones to attach them to it, you're not going to get that size or power. So we start here with the scapula, and if you notice that scapula has a lot of nice surface area on it. We're going to get your infraspinatus muscle down here underneath, your supraspinatus muscle up here on the top, part of your rotator cuff right. If you're not in my section of the lab, you don't need to know that, but if you are in my sections of the lab, pay attention. And now what winds up happening is we have a whole lot of stuff, these muscles, to give us the power we need coming out of the upper limb. Now, from there, your scapula, this is the spine of your scapula. We got this nice body here, and then we've got the glenoid process, the acromial process, the coracoid process, and the glenoid cavity, which is going to give us your actual shoulder. And you can feel that here. You can actually, your scapula starts back here, but it actually ends up here in the front of your shoulder, and that's what your clavicle, your collarbone, is actually coming up and touching against, this acromial process. That's why this is called the acromial region of your body, from this process right there. Yes? Now, one of the things that you're going to need to do is know left versus right at a disarticulated skeleton. Well, this sounds like it should be a really tough project, but to be perfectly honest, it's not. What you're going to need to understand is first is you're going to attach your muscles around the spine. This here, that spine, part of it is to attach the muscles, and the muscles fill that in. And the muscles fill this part in. So when you're actually looking at the model, it just looks like muscle, white line muscle, right? So that needs to face out. This flat piece, that goes up against the rib cage. And so first step is just which is going deep, which is going superficial. And if you look at this, it makes quite a bit of sense why that would be that way. Because if you try to put that spine in, it's just going to get in the way. So we need the spine facing out. We also need this glenoid cavity to face lateral, not medial. The challenge here is we're just going to put the bone on. And you can't touch anything, right? So you've got to be able to look at that thing and kind of like organize your body in such a way where it makes sense. And then this is how if I see people spinning around on this practical, I know they're winning. Because that means they've actually got it, right? So spine out, glenoid cavity lateral, and this, therefore, is a right scapula. And that's the easiest way to come up with this. Don't make this too complicated. Come up with 2 or 3 important rules, memorize those, leave all the detail behind. We've got too much other crap to know, yeah? And so scapula. Questions here? All right. And that's everything we said. The clavicle, you don't need to know left versus right. You just need to be able to understand that this is your collarbone. You should also be able to do this. This articulated is just this S-looking bone. It's the only S-looking bone we got. Left versus right is not a thing in any of the sections to my knowledge. So just understand clavicle is here. It articulates with your scapula and with the manubrium of your sternum. Then we've got the humerus, your upper arm bone. There we go. And this is another one of those left versus right suckers. So let's take this out and take a good look at it. We're also going to need an olecranon process. All right, so this is the olecranon region of your body, right? Your elbow. And what we need to understand is it's called the olecranon because we've got an olecranon process of your ulna. And so your elbow feels like it's part of your upper arm, but really your elbow is part of your forearm. It's that piece right there. That is your elbow. You see this? And in order to get left versus right on this sucker, what we really need to do is understand how your elbow forms. Well, it forms at the joint. It's a hinge joint. It articulates with your humerus. Now, this humerus has 2 basic sides. It's got a side with a basin in the back, in the center. That's called the olecranon fossa. And then it's got a side that's really smooth and round on the front. That's called the trochlea and the capitulum. And what's going to happen is this olecranon process in the back is going to wrap around that trochlea and capitulum in front, and the olecranon process will fit into the olecranon fossa and give you a straight up hinge joint. See how that works? Now notice, the elbow points backwards, right? And so if we're going to figure out left versus right with a humerus, what you need to do is put the olecranon fossa pointing backwards. We've also got a very smooth part right here for articulation. Anytime you see something super smooth, that's been ground down or evolved to be smooth so we reduce friction. That means we're going to be articulating there. And so we've got the head of the humerus pointing medial. We've got the olecranon fossa, the space in the center, pointing backwards or dorsal, and therefore this guy is a right humerus. The other way you could look at this is you could say, all right, head facing medial, and the capitulum, the rounded articular surface facing forward. And in that case, you're going to get the same basic answer. In this case, my capitulum is facing forward, head facing inside, so this bone I'm holding is a left humerus. Questions? Okay. And again, keep your rules simple as you're studying this stuff. There's a lot of stuff to remember. Don't confuse yourself on purpose. Radius and ulna, we do not need to know left versus right, or to my knowledge, as individual bones, but you just need to know that these are your forearm bones. You also need to know that radius is the thumb side, ulna is the pinky side. And after that, you're good to go. Questions there? All right. And with your bones of the hand, your bones themselves, these guys are called phalanges. Then you've got the hand bones proper here. Those are your metacarpals. And then you've got your short wrist bones back here. Those are your carpals. And how the radius and ulna work is they've got these malia on either side, these little protrusions that stick up on the left and right. Your carpals sit down in between those protrusions and are literally trapped there. We tie you down with some ligaments, and now your wrist cannot fall off the edge of your hand because there's literally little speed bumps on either side holding them there by the carpals. Make sense? All right, so the big mistake people make here is to confuse carpals of the wrist with tarsals of the ankle. They're the same system, same basic setup, but the names are different, and you will lose the points if you mislabel, yes? So just keep these guys straight. Wrists are carpals. As we move south, we've got the os coxae, which are your hip bones. This literally means, os coxae literally means bones of the hip. And we're some of the few creatures who have these fused like this. So we've got an ilium, which is a massive place of surface area for the largest muscles you've got in your body, for the most power you've got in your body, right? This is why you've got that power. Lots of surface area for lots of muscle fibers to attach to. We're thinking gluteus maximus attachment and other muscles like this, yes? Knowing left versus right becomes a thing, and so we've got the ilium up top. We've got the ischium at the bottom. The ischium is what you're sitting on right now, and about 40 minutes into the lesson, you can probably start to feel the soft tissue between the ischium and the chair start to bother you a little bit, right? And that's because you've got maybe a half an inch worth of soft tissue between literally a rock and a hard place, yes? So what we've got is a ball and socket joint. This is called the acetabellum, and that ball and socket joint needs to face lateral. The other thing that needs to happen is this sciatic notch needs to face dorsal, back, right? And this nice, beautiful surface area here that's smooth on that side needs to point lateral. You see how we've got this rough side here on your ilium, but a much smoother side there? This rough side here is so we can articulate with a sacrum, like so. The smooth side, you don't get the same articulation. So that rough side is going to be pointed medial. Acetabellum is going to be pointed lateral. This smooth spot is going to be out. And so this is a right os coxae, or bone of the hip. Questions here? For my guys, you need to know not left versus right of the hip, but you need to know male versus female. Remember about the orientation of the ilium, how a male is going to be much more up and down, how a female is going to be flared to the side, how the canal formed by these three bones is going to be much narrower in a male, much wider and round in a female, and how in a male we're going to see a curved sacrum and coccyx versus a female it's going to be much flatter, opening up that birth canal so you might actually get a baby through it. Male versus female in my sections, left versus right in everybody else. Questions? All right. Your femur. Largest bone in your body, hardest to break. What we've got here is femur. Obviously, the head is going to be pointing into the acetabellum of the hip. That's your ball and socket joint. So that sucker got to be pointed medial. And then it's just a matter of understanding how the tibia of your lower leg articulates here at the knee, because this could make some confusion, right? Now, we've got a notch in here in the center, and we've got a much deeper notch in the center on this side. But understand how the tibia is going to work here. I've got my tibia. That's all right. No, I don't. There. If we've got your tibia, what you're going to do is you're going to see these condyles there and these guys here. And how this works is we kick like this. Yes? So if you look, this smooth surface, this condylar surface, kind of rolls up the back. It doesn't roll up this side at all. It rolls all the way up here. And this is so you have a nice smooth surface so you can do the move, right? That's this. And so if that's the case, then what we need to do is we need to put the head medial and we need to put these condyles back. And in this case, a right femur. Very simple, easy to remember rules here. Don't get lost in the details. Questions? Next